Howdy, and welcome to this lecture about how to use algebra to solve percent change. Okay, so one thing to note about algebra is remember that it's simply a manipulation of an equation of variables. Very often, what algebra will use is an equation with just one variable. So, for example, we're very familiar with the equation y equals mx plus b. And y is what we would call the dependent variable. M is what we would call the slope. X is what we would call the independent variable. And b is what we call the y-intercept. So for right now, don't worry about these terms of slope and y-intercept, but instead think about the y and the x term, the dependent variable and the independent variable. Y is describing something that depends on x. So depending on what x is, that's going to influence the value of y. And of course, that relationship occurs according to what the slope of that relationship is and what the y-intercept of that relationship is. So a good example would be, say, you wanted to buy apples, right? And so you wanted to know what the cost of the purchase of the apples is, right? And we would say that this would, for example, be y. Well, y is going to depend on the cost of one apple, and that would, for example, be m. And then it's also going to depend on the number of apples that you buy. And so that would be x. And in this case, just to complete the example, the y-intercept b would be equal to 0. So if you wanted to know what the total cost of a bushel of apples is, for example, it would be y is equal, the cost of those apples is equal to the cost of one apple times the number of apples that you buy. The cost of the total number of apples depends on the number of apples that you buy. And so y is the dependent variable, x is the independent variable. So how do we use this to solve percent change, right? So very often we're told that the price of an object is decreased by 20%, or we're told that the markup on a product is 30%, or if it's a good year, we're told that we're going to get a 5% raise in our salary. And these are all examples of percent change. Whenever that percent is given, it's given the percent change. And one of the common questions, or one of the common things that we would like to know about a percent change is, what is the result of that percent change, right? In other words, if we say that we're going to get a 5% salary, what's our new salary going to be, right? Or if we're told that a product at a store is on sale for 20%, well, what is the actual price that I pay for that product? And so we can think of this as an algebraic equation, right? Where if we say, for example, the original value of something, maybe it's the original price, but we'll say just the original value, plus the change in that value is equal to the new value. So for example, my salary might be $10,000 a year, and I might get a raise of $1,000, so that would be the change, and that then results in a new salary of $11,000 a year, okay? And then if we wanted to determine what the percent change of that is, well, that's simply defined as follows, where we can say that the percent change is equal to the change divided by the original value. And so if we use this example of a $1,000 raise in salary, well, the percent change is simply that $1,000 divided by the original value, which is $10,000. And so that's, of course, 10%. It's a nice raise to have. Okay, so oftentimes, these two equations, right, where we have this original value plus the change is equal to the new value, and then we also have our percent change equation where percent change is equal to the change divided by the original value. Sometimes we're given pieces of information that are not as clear as what they're listed in this equation. Very often we're given what the change is, and then we're told what that change is as a percent change. But we're not given any information about the original value or the new value. And so that can be a very challenging problem to think through. So for example, I might be told that I'm getting a $1,000 raise and that this is a 10% raise. And so then I might be wondering, okay, well, what does that mean my new salary will be, right? I mean, I probably would know this, but let's suppose I didn't know what my salary was, and if all I'm told is that I'm getting a $1,000 raise and that's 10% of my salary, I still want to know what is my new salary, right? And so the question becomes, well, how do I use these two equations to solve for that, okay? Well, it's actually pretty straightforward, and one thing that you always want to remember is that in algebra, you have to have the right number of equations for the number of unknowns that you have. So for example, if I have one unknown, I only need to have one equation. Okay, so what do I mean by that? Well, let's look back up here at this example of the cost of apples. Okay, my unknown is the cost of apples, right? But my known would be the number of apples that I buy. So I only need one equation. I only need one equation to tell me what the cost of my apples is by knowing what the number of apples that I have is, okay? Now, in the example where we have percent change, if I want to know both the new salary or the new value and the percent change, well, those are two different unknowns, right? The new value and the percent change, those are two separate independent pieces of information, okay? So in order to know those two pieces of information, I have to have two equations. I can't just rely on one equation to give me both pieces of information. And that's what I have written here, right? I have the first equation, original value plus change is new value. That gives me the one piece of information, that is, what is the new value? But if I want to know the percent change, then I need a second equation. And that's what equation number 2 is telling me, where percent change is defined as the change divided by the original value, okay? Even though change and original value appear in equation number 1, they're used differently relative to each other so that they're giving a unique second piece of information, okay? Okay, well, let's use this in an example, okay? So let's suppose that we have a stereo, and this stereo is marked down, so it's on sale, $75. Okay, so we're being told what the change is, right? We're being told that the stereo is marked down by a certain amount of money, and so that certain amount of money, that $75, is the change in the price of the stereo. Now, we're also told what the percent change is. So we're told if this is a 15% decrease. Okay, so now we're being told what the percent change is. Then we're being asked to find what the sale price is. Find the sale price. Okay, so let me just kind of mark, using these same terms that we have up here for equations 1 and 2, what's being told in our problem statement. Okay, so first of all, the $75, that's the change. The 15%, that one's kind of easy to detect. That's the percent change. And then the sale price would be the new value. Okay? So we're given two pieces of information, and we're asked to find the sale price. Okay? So let's go ahead and use equation number 1 and see if we can determine this. Okay, so using equation number 1, we get that the original value plus the change equals the new value. So I'm going to use the same terms that we have in the example statement so that we can relate to this problem a little more easily. So the original value, well, that's the same as the original price of the stereo. So we have the original price, okay? And then we have the marked down price of $75. Well, notice how I have equation 1 written. It's original value plus the change. Okay, so I could write this as original price plus the markdown, okay? But I just have to remember that when I go to put numbers into this equation, that markdown is actually a negative value, right? It's being marked down $75, okay? So I just have to remember that. And I'm going to go ahead and include that minus sign right now, right? I have a plus sign in equation 1, but my change is negative, right? And so I want to make sure that I remember that minus sign. So I'm going to write this as original price minus the markdown. That's my change. And this is equal to the sale price. Okay, let's take a look at this equation. I know the markdown, that's the $75. But I don't know the original price, and I don't know the sale price. So I have two unknowns, but only one equation. So if I want to determine what the sale price is, I have to think of another equation, okay? And of course, the second equation that we're going to use is equation number 2. Percent change is equal to change divided by original value. So again, now using equation 2, the percent change is equal to our change divided by the original value. So now if I use the same words that are in the example problem statement, we look first of all at this 15%, okay? That 15% is the markdown, what we would call the markdown, okay? The percent markdown. So even though the problem statement doesn't say negative 15%, we know that it's a 15% decrease. We know that it's a markdown percent. And so in order to be consistent with everything, what we'll do is we'll say that this is negative percent markdown, and this is equal to negative markdown divided by original price. And now look at what we can do. And this is where our algebra becomes particularly powerful. Let's take a look at equation 1. We have original price in equation 1, and we have original price in equation 2. We have markdown in equation 1, and we have markdown in equation 2. We have sale price in equation 1, but we don't have sale price in equation 2. So what pieces of information do we actually know? What do we have values for? Well, we have value for markdown, that's $75, but we don't have a value for original price. Sale price is what we're trying to find. If I look at equation 2, I have a value for markdown, I have a value for percent markdown, but I don't have a value for original price. And original price is not the value that we're trying to find. We're trying to find the value of sale price. So it's to our benefit if we can eliminate this variable original price from our equation. And we can do that by manipulating equation 2 such that we can substitute the result of equation 2 into equation 1, into original price for equation 1. So what do I mean by that? Well, if I multiply original price by both sides of the equation, I eliminate it on this side, and so I then get original price times negative percent markdown is equal to negative markdown. And then if I divide both sides of the equation by percent markdown, I get original price by itself. And so I can get original price is equal to negative markdown divided by negative percent markdown. And now I can take this expression for original price and I can substitute it back up into equation 1. And so I'm going to substitute into equation 1. So what that looks like is the following. We get negative markdown divided by negative percent markdown minus markdown is equal to sale price. So I know what markdown is. That's just $75. I know what percent markdown is. That's my 15%. And I know what markdown is. That's my $75. And sale price is what I'm trying to find. So I can now substitute values for each of these variables. So I get $75 divided by 15%, which is 15 over 100, right? Remember that I have to properly account for that percent symbol, minus $75. And that's all equal to the sale price. So now we have to follow our order of operations, right? And when it comes to division, we always want to start at the bottom and work up. So the first division that we do is 15 divided by 100. That's 0.15. And then we go 75 divided by 0.15. And so we have negative 75 divided by negative 0.15 minus 75 is equal to the sale price. And so negative 75 divided by 0.15 is $500 minus 75, that's the markdown, is equal to the sale price. Now, it's not necessarily clear in the math that we just did, but that 75 divided by 0.15 is giving us the original price of the stereo. So the price is originally valued at $500, but it's being marked down $75, and so the sale price of the stereo is $425. And that's our final answer. Okay, so let's do another example, and we can go through this one a little more quickly since we've taken more time on the first example that we did. So in the second example, we have a person receiving a raise of $162.50. We're then told that $162.50 represented a 6.5% increase. The question becomes, what is the person's salary after the raise? Okay. So if I use just the basic definition of the two equations that we have, right, where we say equation 1 is original value plus change equals new value, and then percent change equals change divided by original value, right? So the first equation is original value plus change equals new value. That's equation number 1. And then equation number 2 is percent change is equal to change divided by original value. I can go ahead and so if I just think about the information that's given in the problem statement, the change is the 162.50. So this is the change. And then, of course, the 6.5% is the percent change. And so when I look at my two equations, I know my change, I know my percent change, and I'm trying to find the new value. What I don't really have any information about is the original value. So I'm going to use equation number 2 to solve for original value and then substitute that back into equation 1 so that I can find out the new value. Okay? So using equation number 2, we get that the original value, and I'm just going to go ahead and do the algebra here already. The original value is equal to the change divided by the percent change. And I'm going to substitute this back into 1. And so original value is just change divided by percent change. That's the original value. Plus change is equal to new value. And so now I know my change, I know my percent change, so I can find my new value. So the change was 162.50. The percent change is 6.5%, which remember is 6.5 divided by 100, plus the change, which is 162.50, and that equals the new value. So when I go ahead and calculate all of this out, I get a new value that is equal to 2662.50. And so that is the new salary after the raise has been put into place.